Swayam Prabha. Digital India. Educated India.
Welcome to this lecture number 16, in which the topics covered are well flow for special conditions, followed by partially penetrating wells. It will be followed by horizontal wells and collector wells, and lastly the lecture will end with multiple well systems. Now we will start with the first topic of this lecture, that is well flow for special conditions. So, in this topic, so the depending upon the three parameters, that is upon aquifer, comma well and pumping conditions, so different types of well flows can be observed. I am sorry, it's can be observed. And again, so this is as we see, so this aquifer, well as well as pumping conditions. So these are three such a vital parameters, so which may make the things quite intensive and quite complicated. So therefore, we will not be able to focus very much into these parameters. So at least so here, so the but researchers have obtained solutions for the problems consisting of different aquifer conditions, different well conditions as well as different pumping conditions for the following special situations or circumstances. So that is solutions have been obtained by various researchers for the following situations involving any or all of the above three conditions. So these three conditions mean the aquifer conditions, the well condition as well as the pumping conditions. So based on this, for different situations, so the which are listed here, so the solutions have been obtained by various researchers. So these different situations are listed here. The first one is the constant well discharge, and we already have discussed many of these constant well discharge situation, and this is followed by varying stroke cyclic stroke intermittent discharge situations, and next we will go to the next situation is sloping aquifers or sloping aquifer situations followed by variable thickness aquifer situations followed by two-layered aquifer situations followed by anisotropic aquifer situations followed by aquifer conditions aquifer situations varying with depth. So next it is so these are corresponding to the aquifer conditions. Then the well, that is the large diameter wells, large diameter well situations followed by collector well situations followed by wells with multiple sectioned well screens. Sectioned well screen situations, etc. So here we should not restrict, we should not be under the impression that so these are the only 10 situations which we may encounter. After all, it is groundwater which is the subsurface water, and then so the situation may depend upon the various this one. It may depend upon the various aquifer conditions or well condition or pumping conditions or combination of any of these three. So therefore, so these are the 10 major situations which the researchers have considered and then obtained solutions. So these solutions are fully analytical solutions. They are analytical come field or experimental solutions, or it is fully experimental solutions or combination of others. So this is actually this is how well flow for special conditions involving the either aquifer or well or different kind of pumping conditions is handled. With this we will go to the next topic of this lecture, that is on partially penetrating wells. So, here we should note that some of the wells do not penetrate for the entire thickness of the aquifer. So, here such wells are known as partially penetrating wells. So, the wells which do not or rather which are not dug or say drilled till the bottom confining layer of the aquifer are called partially penetrating wells. It is a very simple and straightforward concept. So, in case of this partially penetrating wells, unlike the fully penetrating well, wherein so there is a radially inward flow all around the circumference of the well. So, whereas in case of this partially penetrating wells, the flow is even more slightly, I should say slightly more complicated in the sense. So, there is flow not only through the inner surface of the inner cylindrical surface of the well, but also through the bottom, the horizontal surface of the well, or say the bottom of the well. So, therefore, in this case, unlike the fully penetrating wells, wherein we assume that the streamlines, the flow is radially inward and in the horizontal direction. Of course, there has to be some slope, but for simplicity we do assume that the flow is horizontal, radially inwards and horizontal. Whereas, in this case, so the especially on the bottom, the flow will be in the upward inclined direction, whereas in case of the through the sides, that is the cylindrical curved this inward surface of the partially penetrating well, the flow will be generally or mildly sloping horizontal as well as radially inward flow. And so, the following sketch will represent these three. So, let us say this is let us consider for simplicity one water table aquifer. So, sticking to the convention of green for water table, and so this is water table, and then there is this ground level, and in this case let me show a fully penetrating well as well as a partially penetrating well. So, this is the bottom confining layer, and here in this case let us say So, this is a fully penetrating well. Of course, say this, there will be an opening here obviously, and there is also another well which is partially penetrating. Let us say it just is dug only up to say this much fraction, and then below this, even though it is an aquifer, so this is a unconfined aquifer, and then similarly, so this is here, so this is a fully penetrating well in an unconfined aquifer, whereas this is partially penetrating well in an unconfined aquifer. Let me show here with the break line. So, in this case, now let us say, suppose these are the flow lines into this fully penetrating well, which are almost horizontal, whereas in case of this partially penetrating well, so of course here also through the cylindrical surface, the flow lines are radially inward and almost horizontal, whereas through the bottom also there will be some groundwater, and in this case, so these both are this discharging wells, which is represented by this Q, letter Q. So, here, so therefore, we do get the upward flow, or in the inclined direction, inclined upward flow through the bottom of this partially penetrating well. So, here, so we can write down, so this is groundwater contribution only through cylindrical side surface of the well, whereas in this case GW stands for groundwater contribution through, that is side cylindrical surface and that is the bottom surface of the well. So, through the side cylindrical surface, it will be mostly horizontal, radially inward and mostly horizontal flow, whereas through the bottom it is an upward inclined flow. So, therefore, so here we can denote this as so this is in case of an unconfined aquifer. Now, let us also consider a confined aquifer, a partially penetrating well in a confined aquifer. Partially penetrating well in a confined aquifer. Of course, it is not much different from partially penetrating well in an unconfined aquifer. Only thing is, in case of confined aquifer, so it is the flow takes place under pressure, and suppose this is the let us say this is the so this is the ground level, and then this is the water table, and let us also consider, say suppose this is the bottom confining layer of the confined aquifer, and then say let us say this is the top confining layer. And say let us say this is the so this is the aqueous fluid or the impervious layer which distinguishes this unconfined aquifer, which is at the top, and the confined aquifer. So, this is the unconfined aquifer, and this is the confined aquifer. And in this case, so this is the original water table or piezometric surface, original piezometric surface denoted by this letter Wt, and then so here with this full had the well been fully penetrating, maybe let me show it here. So, this is and say this is the original piezometric surface. So, this is also the same. Original piezometric surface, let me abbreviate this as OPS, and here this is original piezometric surface, and this is a fully penetrating well. this is the partially penetrating well, and in this case this is a and here we have, so this is a fully penetrating well. In a confined aquifer, and obviously, so this is the center line of the well, partially penetrating well. This is the center line of the fully penetrating well, and so these are the, so this is the, both are discharging wells, and in this case, so what will happen is, in case of a full penetration, so the drawdown curve will be somewhat like this, whereas for the same this one, the drawdown curve for partially penetrating well in the same confined aquifer, I am sorry, so I am sorry I used the wrong color, this one. So whereas in case of this partially penetrating well, this one, the drawdown in this case, if we denote this drawdown by the letter SP representing the drawdown for partially penetrating well, and whereas in this case, so the drawdown for fully penetrating well, in this case we can write down the relationship, that is SP, that is the drawdown, is greater than S. And so in case of this one, so the streamlines will be like this, whereas in case of fully penetrating well, so obviously the streamlines are almost horizontal and radially inwards, like this. So in case of partially penetrating well, so the drawdown, so this is a higher drawdown, and as compared to a fully penetrating well. Okay, so this is a drawdown slightly lower. So this is the higher drawdown for partially penetrating well, and drawdown slightly lower, so this is for fully penetrating well. Okay, and here so like this, so the area of the circle of influence, they all may be more or less the same, but only thing is, in case of partially penetrating well, so the drawdown will be more, for the simple reason that the area which is absorbed, which is drawing water, is more, because this area which draws water is the not only the cylindrical curved surface, but also the bottom surface of the well, which in most of the cases is horizontal. So, therefore, since the area is more, so then obviously the amount of water extract is also more, and then so therefore, the drawdown in case of partially penetrating well is more. So, with this we will this will complete the second topic of today's lecture, and today we will go to, and then this next we will go to the third topic, which is on horizontal wells and collector wells. And here, so these horizontal wells play a very major role in especially in providing the large amount of groundwater that is required generally in case of say municipal water supply schemes. So, here, so for the simple reason that the horizontal wells, so they are basically there the flow into the well is along the axis of the horizontal well, whereas in case of these vertical penetrating wells, the flow is perpendicular to the well axis. The groundwater flow is perpendicular to the well axis, whereas in case of horizontal this one and the horizontal wells, so the actual flow is perpendicular to the horizontal well axis, but the combined flow is along the horizontal well axis. So, here, so therefore, they play a very vital role in providing the adequate groundwater supply. So, here horizontal wells play a vital role in providing the required large volume of groundwater, especially in case of municipal water supply schemes. So, here this and then of course, there is infiltration galleries are type of this one. So, this is infiltration galleries and collector wells. Are also some form of horizontal wells. And in this case, suppose this is the horizontal well, and then followed by, so in this case there is a water table. So, here this is the water table, and here this is the aquifer, and here we will show this is the impervious layer. So this is the impervious layer. So this is the aquifer is here. So here also this is aquifer. And then this is the horizontal well. So this is the and here this is the seepage area, or say which is also generally referred to as simply seep area, and this is the water table, and here we can say, so this is the break line I am showing here. So this is this one wherein the formation of these the groundwater layers is almost in the horizontal direction. So it can also be in the whereas this groundwater, this rocky formations, geological formations may be mostly in the vertical direction also. In such case, so the horizontal well will be somewhat different. So in this case, let us say this is a this is an impervious layer. And here say this is the and then here this is the aquifer, and here let us say this is the water table. So in this case the general formation of the geological formation direction is in the vertical this one. So again here also we can show a horizontal well which will be so this is horizontal well. So this is a horizontal well in an area with almost horizontal geological formations. Similarly, this is a horizontal well so this is this is the horizontal well. In an area having almost vertical geological formations or geolayers. So this horizontal wells, as you can see, so depending upon the in this case obviously the area, that is the seep area, is much more, and so therefore because the gradient in this case is quite less as compared to vertical wells. So, therefore, the Darcy's law will be more applicable, and then obviously that is the reason why the output by these horizontal wells is much more than a regular vertical well. And let me also bring it to the notice of what are known as the collector wells. So, this collector wells is a well which consists of a number of radially symmetrical horizontal wells which join a well which is generally for as one. So, now let us consider collector well. In this case, so this is, suppose this is the top view, and here this is the of course here if you want to there can be a break line. So, this is the pumping unit, so through which the water is pumped. So, this is the sectional view, sectional front view, and so these are so that is horizontal wells, horizontal well components of a collector well. So, this is the sectional front view, and then the same thing, let us draw the top view. So, in the top view, so it will be so here this will be so all this they are radially emanating so here you can show the axis. So, there can be any number of this radial horizontal well wells which together constitute what is known as a collector well. So, in this case so this is the top view of this collector well, and so here, so this is and this is horizontal well components which are generally, so this is they are referred to as screen pipes. And so together, so it will form a collective well. So this is here, this is the, so this is the clear water well, okay, and obviously, so this is the clear water well, and so this is a collector well which is basically a combination of a number of horizontal wells generally located at the same level. And, so here can say this is so this is section. So this is a sectional top view. Of a collector well. So these, so here they play a very vital role in ensuring adequate groundwater supply generally in municipal water supply schemes. So now we will go to, so this completes the third topic, and the last topic of today's lecture is on multiple well systems. As the name itself says, so there are a number of wells which are involved in this multiple well system, and here, so this is a multiple well system. As the name itself, it is self explanatory. So there are a number of these wells which consist this multiple well system, and here, so this is now let us consider, so this is here you can write down, so when cones of depression in near nearby pumping wells overlap with one another they constitute a multiple well system. So, basically a multiple well system has nearby wells, and then so these wells each one of them will have a cone of influence, cone of depression, and then these cone of depressions of these nearby wells, so they will overlap with one another. So, let us show with this one, that is a multiple well system with say 3 wells, wherein the cone of depressions of each of these wells is overlapping. This case, let us say this is the suppose these are the 3 wells. And let us consider that this is the common bottom impervious layer. And each of these wells are discharging wells. So, this is Q1, this is Q2, and then this is say Q3. And each of them, let us say suppose this is the cone of depression for this well, and so there will be another cone of depression for the other . And then similarly the third cone of depression for the so a resultant cone of depression will be something like this. So, this is the resultant, that is composite drawdown curve. For all 3 wells. So, these are the individual drawdown curves for each of the wells, and then so this is the resultant. So, like this, so this multiple well systems as we have, will stop at this, and in the next lecture we will discuss the further topics. Thank you.